Today's project is sponsored by PCBWAY.com. Hey, thanks for stopping and watching this video. If you do like this content, please go ahead and subscribe. Leave a comment, anything will help. So today I'm going to go over and I'm going to show my general purpose board that I built. This is utilizing an ESP32 with Ethernet, 12 volt input. It does have directional diodes and a few other things just to help it as far as reversed. So I'm going to go through and I'll do a really quick build on the hardware itself. I'll show a little bit of the coding and go through and give a demonstration as far as how it functions. I wrote my own little code for this utilizing ESPHome, which is great if you utilize Homeassistant. This is a great little board if you are looking to replace your existing old outdated alarm panel and you're looking to utilize the existing wiring in your house. This has 16 GPIO pins. These can be utilized. These can be utilized as output pins that will generate, our output 3.3 volts. But the way it's currently set up is these are 16 binary sensor inputs. So door, window, motion sensor, water sensor, anything you want to attach to this, you can. Basically, it's 16 dry contacts. All right, go ahead and jump into this. Once again, appreciate you for joining. While I fast forward through the assembly process of this PCB today, I want to take the time to thank today's sponsor, PCBWAY.com. Right now is currently their 9th anniversary. They have quite a bit of savings on their website. Please, if you haven't used them before, it's a great opportunity to get a little savings and try it out for the first time for yourself. They have quite a bit of other services as well, ranging all the way from 3D printing, resin printing, all the way to CNC and injection molding. Once again, I use them for almost every project that I've done. It's a great time to go check them out. All right, here we're going to look at the hardware. I am not sure if you can see the screen. Might do a close-up. First off, let me go ahead and unpull the power. And right now I am feeding Ethernet and 12 volts to the board. Now, first off, this is an optional relay here. The Pico buzzer, which the Pico buzzer and the relay are on the same pin. So the way I kind of anticipate this, if you want to use this as an alarm module, you have an optional switch on here, which will get the Pico buzzer and the relay. This way, if you don't want to use the relay, you can just have the Pico buzzer and that'll be your siren, or you can use the relay to control a secondary buzzer or an alarm, however you want to do it. Either way, tied to the same pin. I have plenty of exposed headers on here for I2C, and it comes kind of in a different flavor as far as ground, SDA, SCL, and then power. Come over here, we have a buck converter that will allow anything up to, I believe, 19 to 20 volts to come in here, and it will drop down to power everything the way it's meant to be powered. Now, keep in mind over here, it does say 12 volts. whatever is on here is what's going to pass through to the 12-volt reel down here. Now these are this is 5-volt reel right here. Now this is being stepped down. Whatever voltage comes in, it's being stepped down to this buck converter, which is providing the output for this. So it's just whatever input voltage is here, output voltage is here. We have it MCP 23017. I'm probably butchering that. Either way, put it up on the screen so you'll see that. All right, that's an MCP 23017. I do have additional header for an ST7789 display. Now, obviously, as you can tell, this is using a WT32 ET01 ESP32. So it's an ESP32 with Ethernet. Now, this does have 5-volt and 12-volt resettable fuses. Also has some directional diodes here, just to prevent from reversing the polarity and causing any damage. We do have directional diodes over on this reel as well, so you're not going to input voltage into this. So the only input voltage coming into this is going to come off your DC 12-volt barrel jack. Now we do have a power indicator here. If you notice, unplug it, LEDs go out, you plug it in, power LED comes on. Now as soon as it connects to the internet and it starts showing activity, this light will flicker. So this light here is going to end up matching the light on the ESP32 for your data connection. So that's showing activity through the data. Now, the display here, you can change the coding to display whatever you want. I have it set to display the connected status along with the IP uptime counter. All right, now let's run through this. We have a total of 16 GPIO pins, along with a ground pin next to each and every one of those. So I can come over here and connect pin 16 to ground. It's going to show on here, by default, I have it set to show closed when it's connected, open when it's let go. So the screen will show the last activity state, along with, as you can tell, the corresponding pin here through Homeassistant. And this is all running ESPHome. And the native API connection to Homeassistant. So as I jump these, you can see a change on the screen here, along with the UI here. All right. Now, if you notice, the LED status on here hasn't updated. That's just get rid of this one. That just happens to be a product of this. So I can still control that LED independent. Change it to whatever color you would like. And this onboard relay, you might want to turn the volume down and turn on the pico buzzer. If you notice, also engages the relay. Now, I will provide the code for all of this. The way I have this set up is, by default, all 16 are binary sensor inputs. You can come here if you want to change this to a switch. You can change binary to false, change switch to true, and then when you rerun the firmware, this right here should disappear as a sensor and reappear as a switch up here with a corresponding name. So that way you can use it as an output, and when turned on, it'll output 3.3 volts, so you can control little buzzers, little LEDs, additional relay boards, and whatnot. So I do want to say overall, so I'm going to go through and show you the PCB board here. So I do want to say there is overall quite a bit going on this little, well, I shouldn't say a little board. I'll provide the dimensions, but there is quite a bit going on this board. And there's just no way to do this without a PCB. I have everything going on here. It's no way to do it without having it on a PCB. I absolutely love building my projects on PCBs.